Okay, this video is intended to help you talk about the conclusions of a chi-square test a bit more in depth. So this assumes you already have done your contingency table. That would be this one here. I've just taken this from a textbook. So you've already got your contingency table, and you've already calculated your expected frequencies, which is down here, this expected table. And you have already compared the two of them by plugging it into this formula, which an example for like this exact one is down here. Again, it's just taken from a textbook. So in the end, you already have some number. And now the question is, what does that number mean? Well, if you just have this number, you can compare it to a critical value. Although when you do this test on any sort of technology, you also would get the p-value. However, I think that it would be a good idea for this report to only use this critical value and then use an actual graph of the probability density function for a chi-square to really see, like, what does this mean? Where does the p-value come from? How does it compare to a critical value? Like, what do these things mean? So one thing we can do quickly is to look at, I have left it, I don't know where it is. Okay, so here's a graphic that I made. It's online. You can see the address here, or you could probably just search for it, like GeoGebra chi-square test of independence. I don't really know how you would find it. But this is an interactive graphic that I have that should hopefully help you understand what the chi-square test means. So this little like round curve here, I hope you can see my mouse. So the roundness of this curve is the chi-square function. It's the probability density function for a chi-square. This one happens to be for 8 degrees of freedom, but you should be able to click this over, if only it were actually reacting to my clicks. Sorry for the slowness of my computer in this moment. So you can move it over and you could see like 3 degrees of freedom or 4, even down to 1. But you'll notice the curve changes a bit and it actually sort of loses that hump as you get fewer and fewer degrees of freedom. So just so we can see it well, let's put it back to 4. I don't know, sure, 6. So this is what the curve looks like. Now you can move around this like purple dot, and that's the calculated value. So in the test we just did, in fact, actually, let's go back to that one. There are here 3 degrees of freedom. So I can come back. Let's see if I can get this to go down to 3 without causing trouble. 3 degrees of freedom, and then the value we got was like so big it's not even on this graph. So whatever. Here I have 26. The actual outcome was like 33.8, so it's very, very, very high. Now for this particular test, this 3 degrees of freedom, I have this blue shaded area. And the blue shaded area is always 5% of the total area under the curve, or 0.05, because I've set my test to have a 95% confidence level. So my alpha or my significance level is 5%. You could, of course, change this to be 10% or 1%, but 5% is the most standard. And if you did anything besides 10, 5, or 1%, that would be kind of strange. So I've just left it at 5%, which I think is a reasonable thing to do. So what happens is that I'm shading in the curve, like starting at the top and coming backwards down to the left until 5% of the area under the curve is shaded in, and then it just stops and it cuts it off, and that's my critical value. So in this case, the critical value is 7.81. And notice, as I move this purple thing, when I get to the left of the critical value, that's do not reject. But as soon as I get past that critical value, I reject it. So in this example case, we would be rejecting the null hypothesis. I didn't even write it down because for this portion, it's not really important. It's something that you should have already discussed in your paper before. So let's talk about all these values. This critical value, the 7.81, is the number at which this chi-square with this degrees of freedom will have 5% likelihood to be to the right. So the probability that the number I get is bigger than 7.81 is only 5% if if the assumptions of the model are true. And since it's so unlikely that the model is correct, if you're getting a number that's higher than that, that's what you would reject. So this critical value really only depends on the degrees of freedom because it always will calculate 5% of the area under the curve of this right-hand tail. So it's always the same for whichever degree of freedom. It'll change if you change the degrees of freedom, but it's always the same for whichever one. So anybody doing a chi-square test with 3 degrees of freedom, every time it's going to be 7.81. It'll never be different. This chi-square calculated value is the one that you get by adding together all those squared differences. And this alpha, as I mentioned before, it's something that the researcher sets. You set it to be a percentage, and it's this blue shaded area under the curve. And the p-value is something that is typically calculated for you, but is really extremely important and I think rather interesting. So notice the p-value changes as I move this purple thing. And the p-value is also a shaded area to the right of my curve, or to the right of this value. It's the shaded area to the right of my calculated value. It's then the probability that some value would be higher than my calculated value. So like right here, I could say this like, okay, in a chi-square 3 degree of freedom, the probability that the value I get comes to be 2.9 or higher is 41%. This here. And again, in this example, I know I don't reject. I know because I can see with the critical value and the calculated value up here, comparing the 2.7 or the 7.81 and the 2.9. But I can also, for this test and for every test, every hypothesis test ever, I can compare the p-value and the alpha. The p-value is this purple shaded region. And if it's bigger than my blue shaded region, I know I don't reject my test. I only get to reject it when it turns out I'm like way over here to the right of my critical value, so that my p-value is smaller than the alpha. And that is when you'll reject. So I think it would be a good idea for your paper to actually present a curve like this, like show these calculations where they're coming from, rather than just plugging it into a calculator or some other device that will like spit out these critical values for you. So I'm going to show you in this video how to create a graphic similar to this, not this one, because like you don't need all this stuff to the right. Well, kind of. You need some of it, not all of it. So in theory, you can create this online with GeoGebra. It's like a free software. You would just go to, I think I have it here, geogebra.org, and you could click Start Graphing. However, I always have a really hard time getting the in-browser version of this app to work. Like it always has mistakes and is super slow and causes my computer to like have trouble. So I'm going to be doing it in the downloaded version. Depending on how good your patience is, you can choose to do it online, or you can also choose to come down here and download the app for whichever device you're using. The graphic will look the same. It's not really different. It's just that for some reason, every time I try to graph online, it just is a huge, huge hassle. So if you choose to do it online, just click Start Graphing. If you want to download it, go ahead to this app downloads and get the one that's appropriate for your computer. So that said, let's go to, this is what would happen if you just opened it. Oh, I like the GeoGebra Classic 5. There's like a 6 that's out. I'm just not a super big fan of the interface, but it's not really terribly different. So if you want it to look exactly like my screen, you need to get Classic 5. If you get Classic 6, I'm sure you'll figure out like how to do it still. They're not really that different. So here I just have a blank graph. And what I want is this chi-square curve, like that curve that like did the hump down and over. But it needs to be for your degrees of freedom. So I'm just going to keep working on this book example and say that I have 3 degrees of freedom. But that curve, like what is that even? Well, you could go to Wikipedia for chi-square. So if you went to chi-square distribution and you scroll pretty far down until you see this pretty gnarly looking formula, it's right here. This is the probability density function, and it's not really important for this level of understanding for this class that you understand exactly what this function is or how it works, just that you can like copy it down. So I would recommend you like literally write this down on a piece of paper and then go back to GeoGebra and type it in. It's sometimes difficult to slide back and forth between the two. Like it'll think you're entering things when you're not, like if you leave the window. So I've written it down on a piece of paper. And now I'm going to go back to GeoGebra and just type it in. So when I get here, I'm going to come down to the input bar. If you don't have an input bar, you just click on View and make sure that this input bar is checked. And this is a function. Like it's a function on a graph. So I'm just going to start typing the word function and then it will appear. And I want to go to the second one because this function only starts when x is 0. Like there shouldn't be anything graphed to the left. So I pick the second one, and now I have to type in the function. And here's where I have to type in that sort of gross looking thing from Wikipedia. So I'm going to open a bracket because I need to type my numerator there. And it was x to the power, but because it's not a single thing in the power, I need another bracket. It's the degrees of freedom over 2. So in my example, I have 3 degrees of freedom, so I'm doing 3 halves minus 1. Then I get out of there, and I have to do e to the power negative x over 2. But inside GeoGebra, e is actually exp, like it's a known function, and then that's going to be negative x over 2. If I go over, I'm out of that thing, but I just need to be out of the numerator. You can see now that it's green. Like here, my bracket is green, and this very front one is green. Now I know that I've closed that numerator. Now I divide, and I have to open one for the denominator. And in the denominator was 2 to the power, again in brackets because there's a fraction in the exponent. And it was k over 2, where k is your degrees of freedom. So I have 3 degrees of freedom, it's 3 over 2. Oops. Get out of the exponent, and now I need to use this. It's called gamma. It's a function that exists, like the computer knows what it is. So I'm just going to start typing gamma, and I'll pick the top one that comes out. And again, it's the degrees of freedom over 2. So I'll have 3 over 2. If I press right, I can see that it's closing the gamma function. If I press right again, it's closing the denominator. That's fine. I'll press tab to get to the start value. And I wanted to start at 0. And the end value, I mean, it really goes to infinity, but I know that this really levels out early, so I'm just going to put 40, because I won't be able, like, you can see it already on the screen. See how it just popped up? Like, it's after even like 9, nothing interesting is happening on this curve. So I'm just going to press enter, and then it draws it, which is great. The zoom is a little bit rough. So I'm going to click here, and then right click, and I can go to graphics. And that's where I'm going to set it. We know that there doesn't exist anything to the left on this graph, but so I have some space to see things, I'm going to say like negative, I don't know, 1. Just go from negative 1. I can see that the curve really stops once I get to about 10, so maybe for the max I'm going to put in 10. Again, there's no such thing as like negative in these probability functions, so I'm going to put negative 0.02. Yeah, that's probably okay. But also, like, I don't need all this space on top, so I think I'm just going to try 0.2. And it's not really important that you get these right on the first try. See, that was not good. It's too close. So I could change the max, or I can bring my mouse on top of the graph and, like, scroll down, which is actually a zoom out, and I think that's what I'm going to do. I'm just going to zoom out and drag until it's what I want. I actually can see that I do want a little more to the right here. So I'm going to change the max to be 20. Yeah, that's okay for me. It's like a little steep, but it's okay. So now I can close this. Oh wait, no. I want to change my axes. This only goes in the positive direction, so I'd like to get rid of these axes that are to the left, because see, now I don't have like any grid over here. And I actually don't want the grid to show up at all, so I'm going to turn it off. And it's your choice whether you want to keep this y-axis. It's often excluded, so maybe we don't show it at all, or maybe you don't show the numbers. I think it's not really important. Not really a fan of these tick marks. So I think that looks nice. I think I'm ready to adjust my curve. So now I click on the curve, and I still have this properties area open. I do not want to show the name. Like, see how it's showing a little F here? Like, that's not what I wanted. And then the color, I'm going to put this to black. You could also make it a little thicker if you wanted. You can make like the thickness come up. I think it looks fine. I guess I'm going to go to 100% opacity. Sure. So there we go. This is what my curve looks like. So now what I need to show what my critical value is, and I need to show what my calculated value is. Now the calculated value comes from you. Like, you did that before. In this example, it was 33.8. That's way off my graph. I guess I got to change this max. That's annoying. Okay, so now at least there's going to be a space to put my critical value. So what I would recommend is, I guess there's not really an order we need to do these in. Let's go ahead and put the critical value on there. So I'm going to come down here. I'm just going to call it CV, like that's just like the name of my point. Maybe I'll use capital letters because it's a point. Equals, and then in the bracket, I need to put literally what I calculated. So it was, I mean, I didn't do it, the book did it, but 33.8 comma 0, because I want it right on that axis. And you can see it's showing up here in blue. And I press enter, and now it exists. And again, I can come over to this properties area, and I can make it bigger. I can change the point style. I'm just going to change it to, I think I'm going to stick with this maybe, no, let's go with green. I'm going to do mine in green. But I don't want this label. Again, I do maybe want a number showing, but I don't like the way that that label looks. In fact, I'm going to change it to a caption so that it has fancy math text. So you do that with like, you put dollar signs and you write in between. And like a chi-square with a capital CHI is going to make like that pretty Greek letter style. So chi-square. But this was my calculated value. Oh, I've used a CV above. That's really for critical value. So let's go back and change this to calc. That's fine. And then equals, and I wanted to show like the actual x value. See, it's already showing, it's really pretty. And that will be done with this funny percent sign and then x. And if I press enter, now it's going to show up. So it shows that my calculated value is 33.8. I'm going to zoom out a little and bring this up again because I would like this label to be underneath. And you do that just by dragging it. If you don't want the dot to show and you just want the number to show, you would click on show. No, you have to have both showing because of the way that we've set this up here. Sorry. So now I have the calculated value. That's great. But I would like to compare this to the critical value. And the critical value for this test in 3 degrees of freedom, if you don't know what it is already, the critical value, you can calculate it using whatever calculator you have, or we can go ahead and come back to, we can have GeoGebra do it for us. So I'm going to open up a view of a probability calculator. I'll choose chi-square. Degrees of freedom, I'll choose 3. And the whole point of this test is I want this, see how I clicked this guy here? I want this right shaded area to be 0.05, or whatever your significance level is. I'm using 0.05. So here it's 7.8147. I'm just going to copy that. And now I'll do the same thing. I'm going to put like a dot over here. This time it really is going to be called CV. Sorry, I did that wrong before. The X value is 7.8147 and the Y value is still 0. So that adds a new dot. It's blue. I think I would like to make it sort of like a light blue. I don't know why I like them light blue. I just do. And again, I want to change the caption because I wanted to show that I know that that's the critical value. So I'm going to put it between dollar signs, the chi-square, but this time it is the critical value. So I'll do CV equals %x. Again, I'll drag it below. I would even like to draw a vertical bar here. I want like a line segment that goes from this dot up to my curve. It's easy enough. I'll just come down here and put segments. Sure, from one point to another. And the first point, it already exists. It's called CV. I don't have to type it again. But the top point is on my curve. So the X value is this 7.8147, and the Y value is F of 7.8147. It's F because that's what my function was named. Up here, it just automatically called it F. If it had called it G or H, I would need to make sure to call that. But again, this is just how functions work. You have an X value for the X coordinate, and to get the Y coordinate, you simply put the X into the function. So I think that should do it. I gotta close the brackets, and now I can see a line. Great. It automatically puts a name on these lines. It's just how it is. I'm gonna go ahead and turn that off. I don't want the label. I do want the object. I'd like it to match colors, so I'm gonna turn it here, and I'm also gonna make it thicker. I think that 9 was sort of nice. Sure, looks okay. That dot looks a little funny now. Maybe I'm gonna just make it real small. In fact, maybe I also make it a little plus sign so you can't even see it. It sort of just disappears. And that color. Great. I think I'd like my x-axis to be bold. Even better. So I need this to be shaded in. And it's outside the scope of this course that you know how to do that, but to get GeoGebra to do it, we're going to be using an integral. And an integral, when you define two endpoints, is just the shaded region under a curve. So I'll start typing integral, and I'll go down to the third one because I'm going to tell it where to start and where to stop when it's doing this like shading in. So I have the function. I don't have to type the function again. It's already named f of x. I just call it f of x start value. I want it to start at 7.8147 because like that's where this blue line is. Where it ends, I mean, it doesn't really matter, but I think I'll just put like 100. I mean, it does matter. It really should go to infinity, but sometimes I forget how to type infinity in here, if it's like infinity or infty. Infinity seems to be working. Okay, so we'll go from there to infinity. And I press enter, and you can see it labeled. It comes up and it's calling it A, and luckily it is 0.05, which is the whole point. It was supposed to have been 0.05. That's where we got this number from when we used this probability calculator here. Like, these numbers should match and the picture should sort of match. So that's good. But the color is not my jam. So I'm going to change it to blue again. I think I'm going to amp up the opacity. I'm going to turn off that label. I am not interested in it. I mean, I'm interested in the label, but I don't want it to be placed there, and I don't want it to be so small. So I'm just going to turn it off. Great. So I have my critical value. I have my calculated value. I can clearly see my calculated value is higher. Like, I'm definitely rejecting this null hypothesis. But I would also like to have the p-value there. And the p-value is the probability that my calculated value or higher happens under this curve. And clearly it's like almost 0. But we can calculate it here. And we could do it the fancy way with the integral. And that is the way I'm going to do it because I want it to show on the graph. Like, if it were further to the left, I would want this new shaded region to also show up. This is sort of unfortunate that this one's so high. In fact, okay, let's just suspend reality for a moment and pretend that this was smaller. So let's say this was, just so I can see it better, let's go with like 9.8. Okay, so now it's moved over. It no longer matches my example, but it is helpful because now I can actually see it. So what I want to do is I want this shaded area to the right to show up above this green dot. Again, shaded areas are integrals. So I'll come down here to input and I'll start typing integral and I'll go to the third one because also I know I want it to start at 9.8. The function, it's the same as always. It's just this f of x because that's what we started at. And this is going to be 9.8 or whatever my calculated value was. And this will be infinity. Great. Now it's shaded in. It also says it's 0.02. That's my p-value. If I were to have calculated this somewhere else, I also would have gotten that. I also don't like the way that it's displayed here, the same that I didn't like the way it was displayed for alpha. So I'm going to turn off the label, but not because it's wrong, just because I intend to type it better later. I also wish that this were further down. I can't move that. So if in your picture these are too close together, you're going to want to change this. I'll show you how to do that later. And I also don't want this to be whatever color this is, brown. I'm going to change it to green just to match the dot and the text like I had before. I'm going to up the opacity, but I don't want it to cover up the blue one. I want it to be clear that the blue one was in the back. So what I'll do is I'll do this hatching. So then it's this like slashy slash. Actually, I think I'm going to go back and turn off the opacity. Line opacity, good. Line thickness, maybe a little thicker. The spacing, you could do like further apart or closer together. I think, let's see what happens when I turn this opacity off. Can you still see the blue underneath? Not that well. So I think for this area, that's maybe too close together on the spacing. So I'll come back up one. And even maybe the green isn't dark enough. But in any case, this like, now this sort of line shaded region, that's my p-value. And the blue shaded region is my alpha. You can't see these numbers very well. So I think I might consider changing the label to get rid of that chi-square thing. So just have it be %x. And just this number, and then I can type the chi-square elsewhere. So again, that will just be %x. It's still in the dollar sign because I want the numbers to be like sort of like the fancier math scripts. And so there's that part. If I want the labels, I need to be using text. So I come up here. I don't want a slider. I want text. So let's say I want to write on this graph somewhere the critical value. So I would turn this LaTeX formula on because it looks prettier. It's like the better math one. So I do this backward slash chi-square underscore, and then you have to do it in these curly brackets. And let's go ahead and call this the critical value. Well, capital was maybe too big. And the critical value was 7.81. It was like 814 something, but I'm rounding to 2 digits here. And then I can press OK, and it's just going to appear on the screen. It's kind of small. You could choose to make it bigger, so I click on it, and then up here I can go from small to medium. Because I did everything in blue, I could also change the text color to be this blue color I had chosen. And then I'll do the same thing for my calculated value. So I choose the ABC again, I click on the screen anywhere, I make it be a LaTeX formula, and then I do backslash. No. I squared underscore, and this is the calculated value, so I'll call it calc. And it equaled, what did it equal? 9.8. I mean, I remember it was like 33.8, but because I want this picture to show better, I go with 9.8. Again, by default, it's always small and green. I pick this. If you click again without changing it to the little mouse, it's going to just try to keep adding text and you will be annoyed. We'll go with medium. This I had done in this green color. So I could drag this down here if that's where I wanted it. It's personal choice. I don't actually know where to put it. And frankly, this curve, it's just so tall. I'd like it to be less tall. So I'm going to change my Y max to be like, I don't know, 0.5. Yeah, I guess that's okay. I just don't want to have like such a huge, like I'm going to take a screen capture of this to put in my report, and like I don't want it to be so big. But the shorter I make it, the smaller these numbers are. We can try again. So that's 0.38. Oh, I already then made it smaller. What if I do 0.6? Actually, that's nice. Maybe even 0.7? Cool. Okay, so I'll move these around again. So is my calculated, that's my critical value. I know I can reject because if the calculated value is bigger, if it's to the right, then I'll reject my null hypothesis. But I also want to put here my p-value and my significance level. So again, I'll come up to the test. I'll click. The significance level is always called alpha. I don't know why that's true. It's just a style thing. Like somebody called it alpha, and then we were like, sure, we will always use alpha for the significance level. So then we have 0.05. You could choose to put 5%, but if you want to put 5%, you have to do this like backslashy thing to get the percent sign to show because you're inside the LaTeX. I am not going to do that. I'm going to do it as a number. So we have OK. This is the blue shaded region. So I will actually, again, change this to be blue and make it bigger. I'll go to medium, blue. I don't know. Maybe I'll put it in line with this blue one. You can put these anywhere on your screen. Like, it's not important. It's important, but it's your personal choice. There's not like a correct place to put it. And then I want to put my p-value on here. So the p-value is actually already calculated somewhere. In fact, I could have done that for alpha. I don't know why I didn't. So I'm going to turn on the LaTeX formula just because I think it writes prettier. But because this is it going to write funny? I take it back. Okay, so you write text and you do these squiggly brackets, and I do that because otherwise it thinks that you're writing a formula, not like words. So the p-value equals, but we calculated it over here. It's like this thing that they call g. So I go to objects and I pick it. And then it just puts in the number. But now the number is like the nice math format, which is why I was using LaTeX. So I go to OK, go to the mouse, And actually, sometimes it chooses the wrong text. You always want to be using the serif. That's not true. You can use whichever you like. I just don't like the way the sans serif one looks. Like it's no longer fancy math text. It's just sort of normal. So there, I want it to be medium. And I want this one to be green because that's what I've been using for that shaded area. I think it's probably important that you choose the same colors for the shaded area and this cutoff points and for these values. So whichever ones you choose, it doesn't really matter. There's no right or wrong way. Just I think it's probably important that you keep it the same. And then if you wanted to add some sort of title to this, again, you would just do this and then call it whatever you want. If you want it to have normal text, then you just type in and you leave it how it is. See how it's like just the normal font? Oh, I forgot to click the thing. This is what I meant by like it'll just keep trying to give you text. Click the mouse. Click on this and you can change it. In fact, if you want to change it later, you just double click on it and I could just say like hypothesis test. I know that this is a chi-square test of independence, so I might do that, but then I would have to do the LaTeX formula. And then I would have to do like text with these squiggly brackets because the rest is just words. So test of independence. And that would go here. Maybe you make it really big, like large. It doesn't matter. You don't even need this here. You can do that in your actual document. And in fact, you don't absolutely need any of these things, but I do think that does a better job of presenting what it is that you have. And what you have is a shaded area that would tell you if your number is too big. And then you would have your calculated value, and it's either to the right or it's to the left. And if it were to the left, let's say that for some reason my calculated value, I'm just going to change this to be 5.8. It doesn't have to be 0.8, I'm just too lazy to change it. And then that's also going to change this. Oh, that's annoying. Why did I not? I should have cancel. This was the G area. Why does it keep weird thing? Oh, G is the segment. That's not what I wanted. What is this shaded area? Integral. Where's the integral? Oh, it's B. So I need to change. I've done so many things wrong. I need to go back to my p-value. It's not G. I got confused because they're both 0.02. It's B. That should have been obvious because it's blue versus green. So this I need to change now because now it starts at 5.8. So that's what it would look like if I was not rejecting my test, if it turned out that those square differences were actually not that much. So then my observed table and my expected table are pretty similar, which means that the underlying assumption of the test, the underlying assumption of this chi-square is probably true. So that's really it. You can do whatever you like. If you want to make these bigger, you have to like put them in as text and drag it down there. And I think that this would be a nice graphic to include in your report, but it's not absolutely necessary. What is necessary is that you understand when to accept and reject the test and why. And the reason is that if your calculated value, this would then have to be changed as well. If your calculated value is smaller than your critical value, you do not reject. If it's bigger, you do. If the p-value is smaller than the alpha, you reject. If it's bigger, you don't. And that the thing with the p-value and the alpha is true for every single type of hypothesis test, not only the chi-square. So that's it. If you wanted then to have this, you would just take like a screenshot, paste it into your documents, make it look however you like. If you do intend to use this, I think it's probably important that you cite this video as how you learned to make the graphic inside of GeoGebra, and then make sure you're citing whatever source you've used to be able to get the formulas. I was just using the book, like the textbook. So then I would make sure to cite that. I think that's everything. If you have any questions, you can message me directly if you know me as a person. Otherwise, you can comment and maybe one day I will answer.